So this is chapter 5 quiz. Okay, so first one, a truck is using a hook to tow a car whose mass is 1/4 that of the truck. Okay, so there's a truck. Okay, if the force, so if the truck is the car, right, hook. If the force exerted by the truck on the car is 6,000, then the force exerted by the car on the truck is, well, this is a Newton's third law pair. Okay, so this is truck and this is car. Okay, if a truck applies 6,000 newtons force on car, then car apply 6,000 newtons force on truck. Okay. Second one, a person is using a rope to lower a 5.0 Newton bucket. Okay, so this is the 5.0 Newton bucket, right? That's a rope. Lower it. All right, so this is weight. With a constant speed of 2.0 meter. Okay, so constant speed, 2.0 meter per second. Constant speed, right? Which means A is 0. That's the meaning. All right, what is the magnitude of the force exerted by the rope on the bucket? Well, what you do here is do a free body diagram. You have weight, which is 5.0 Newton, and then force, tension, right? Tension. That's all the force on this bucket. Then A is 0, which means net force is 0. Net force equal to tension minus weight, right, is 0. So tension equal to the weight. So weight here is 5.0 Newton, tension is 5.0 Newton. An object that weighs 75 Newton is pulled on a horizontal surface by a horizontal pull of 50 Newton to the right. Okay, so let's just put it here, right? So this guy, 75 Newton, pull 50 Newton to the right. The friction force on the object 30 Newton, 30 Newton. To the left, what is the acceleration of the object? All right, so, well, if you look at the free body diagram, so you have normal force, weight. In vertical direction, you have normal force and weight. It's balanced, right? Horizontal direction, 50 Newton to the right and 30 Newton to the left. So the net force equal to 50 Newton minus 30 Newton. This is in horizontal direction. Okay, so equal to MA. And what is the mass? Mass equal to weight over G, right? So 20 equal to, so 50 minus 30 is 20. And weight is 75, G 90.1, acceleration. Okay, so A equal to 29.81 divided by 75. Let's see what we have. 20 times 9.81 divided by 75. Okay, 2.6. Yeah, you see, 2.6. Number 4. What magnitude of net force is required? Okay, so let's get it away. All right, so number 4. What magnitude net force is required to accelerate this car uniformly from 0 to 27 in this much time? Okay, so this is V naught, Vt, right? Well, looking for the net force equal to ma. Looking for net force, right? And mass equal to 1200 kg. You don't know A. Where we get A? We get A from this kinematic equations, right? So we know V equal to V naught plus AT. So A equal to V minus V naught divided by T. So V is 27 minus 0 divided by T, 10. Okay, so this is 2.7 meter per second squared. That's the A. Then 2.7 times 1200, right? 1200 times 2.7, okay, 3240. Okay, see, 3240. That is net force you need. Okay, so next one. Okay, so next one is a net force of 125. So net force equal to 125 Newton is applied to a certain object. As a result, the object accelerates with an acceleration of 24 meters per second. Okay, so net force or acceleration equal to 24.0 meter per second squared. You see, net force, acceleration. So we can use Newton's law, figure out mass. Mass equal to net force equal to A, right? Divided by A. 125 divided by 24.0. That is the mass. Okay. So we use the Newton's law in a different, from different angle, right? So 125 divided by 24. See 5.21, right? So 5.21, that is a mass. Number 6, a car of mass. Okay, so this is mass that is traveling. Okay, so mass equal to 1100 kg. Traveling, v equal to 27 meters per second. Start to slow down and comes to a complete stop in, okay, so v naught, v equal to 0, right? And the displacement equal to 578 meters. What is the magnitude of the average braking force acting on the car? Okay, so why car stopped? Because of the braking force, right? So you see, braking force is net force, right? So you see this one, car move, right? So you have velocity, then you stopped. If you look at the horizontal direction, you only have one force, it's a friction, and we can consider it's a braking force. Okay. What's net force, right? Net force equal to ma. And what is A? We know M, but we don't know A, right? So you see, we can figure out A from this kinematic equations, right? So we know V squared equal to V naught squared plus 2AD, right? D basically is delta X, right? So A equal to V squared, which must be V naught squared divided by 2D. Okay, so V is 0. V naught is 27 squared to 578, right? So we can tell what is A. 0 minus 27 squared, and then divided by 2, let me see, divided by 2, divided by 578. Okay, so this is negative 0.631, right? Meter per second square. Yes, it's decelerating. Okay, so but it asks you about the magnitude of the force. Okay, so plug here, right? So this is the 1100 times, which is the magnitude, right? So 0.631. Okay, so 693. 693. So answer is 693. This guy. Just find the closest one. Number 7. If you pound a feather with a hammer, which one feels greater force? Okay, so hammer, right? Feather. Okay, some object, right? So if you this guy down, then pound it, right? So this is basically Newton's sort of pair. Hammer put a force on feather, feather put a force back on hammer. Same magnitude, always same magnitude, opposite direction on different object. Okay, so the size of the force is always exactly same on both of them. Newton's law pair. Number 8. The acceleration due to gravity is lower on the moon than on Earth. Which one of the following statements is true about the mass and weight? Okay, so mass and weight of an astronaut on the moon's surface compared to the Earth. So basically, mass is the same, weight equal to mg, right? So if g is different, weight will be different. Okay, so here A, both mass and weight are the same, wrong. B, mass is less, weight is more, wrong. Because g Earth, because E, right, equal to 9.81 meter per second squared. G moon equal to 1.6 meter per second squared. So on the moon, gravitational acceleration is smaller than Earth. C, mass is the same, weight is less. Okay, so this is good, right? Both mass and weight are less, wrong. Okay, so mass is always same, but the weight on moon will be smaller. All right, so that's all for this quiz.